So in our previous class, we have discussed about your summit curve, and we have solved some numericals on the summit curve. So basically, you know the design of the summit curve. Just a minute. Okay, so basically next uh, we have to discuss about the Bailey curves. So in the case of design of the summit curve, you already we have discussed that the design consideration of the summit curve design based on the side distance consideration. So basically, in the design of the summit curve, you have to design that summit curve on the basis of the side distance, whether that is a stopping side distance or overtaking side distance. Okay, because in the summit curve there is no discomfort to the passengers. But in case of Bailey curves, what happens? There are some discomfort of the passengers. Okay, why? Because in that case, your centrifugal force is acting downward, and which will increase the pressure on the vehicle suspensions and tires, and for that reason, that the passengers will feel more weight. Okay, for that reason, in the summit curve, that will be provide discomfort to the users. So in this case, okay, so for this reason, what happens in the design of the summit curve, sorry, in the design of the valley curve, you have to consider for the comfort condition. Okay. Now, if you go for the valley curves, basically this is the shape of the valley curves. Okay, suppose there are here, two gradients are meeting with each other. In that case, suppose they are forming one valley curve over here. Okay. Now the thing is, see here, these would be straight line. Here, that would be straight line. Now, if you just simply go for a circular curve over here, in that case, what will happen? Suppose you provide circular curve over there. In that case, what will happen? That in that case, over here, up to that point, your centrifugal force should be zero because there is no curvature. But whenever the vehicle reaches at that particular position, suddenly there will be a centrifugal force because at the no time here you are applying your radius of the curve. Okay, at the sudden you are implying one circular curve over there. Okay, so in that case, what will happen? That the vehicle will feel like sudden uh, discomfort, sudden jerk, like that. So in such cases, what you have to do, you have to gradually introduce the curve. Okay, you have to gradually introduce the curve so that you can check the centrifugal ratio. So in such cases, what you have to do, your uh, instead of any circular curve or parabolic curve where the radius are fixed, you will fix some curve for which your radius is not fixed. Radiuses are varying. Okay, so this type of curves for which your radiuses are varying. Okay, radiuses are varying means either they are decreasing or they are increasing. They are not fixed. That type of curve is called transition curve. And this type of curve is intended to transit the vehicles from one point to another, keeping in view of all these centrifugal force and comfort condition. So basically, this is one use of the transition curve. Now there are another use of transition curve which is very important. In case of horizontal curve, in case of horizontal curve, if you go for the horizontal curve, what will happen? Suppose this is one road and that is another road, and you place one circular curve over here. Okay. So in such cases also, what will happen in case of the horizontal curve? Your centrifugal force will be acting in the outward direction. Okay. Now at that point, when the line was straight, at that point there will be no radius, no curvature. Therefore, centrifugal force would be your zero. Okay. At that particular point, your centrifugal force would be zero. Again, at that particular point, your centrifugal force would be zero. But within that time, whenever you just cross that particular point, in that case, you will feel sudden centrifugal force. Okay, you will feel sudden centrifugal force. So for that reason also transition curves are used in the horizontal curve also. So how transition curves are used in the horizontal curve? Let us see. Suppose for these examples, these are the extra widening provided in the horizontal curve. Okay, up to here, these are your straight path. Okay, up to here, this is your straight path. Now consider if from that point only, if you provide one circular curve like that, in that case, the centrifugal force over here would be sudden. Okay, but you need gradual introduction of the centrifugal force. Okay, so for that reason, you will place transition curve at that point, at the starting point and at the end point, so that that transition can happen swiftly from the straight line to the circular one. Okay, so basically for this reason, this is called transition curve because it helps in transition of from one point to another. Now, how these transition curves will help in? So for the straight line, if you go for the straight line, your radius would be infinite. Radius of the straight line would be infinite for the straight line. Okay. And for the circular curve, here would be some radius would be there. Okay. Suppose for that circular curve, one radius would be there. Suppose that radius is r. Okay. So at that point also this radius is r. At this point also the radius is r. For the circular curve, radius would be similar. Same. Now the thing is at that point, at the straight line point, your radius is infinite. Okay. And if you introduce your circular curve over there, in that case, suddenly you will feel that there are, so there would be your centrifugal force, sudden increase of the centrifugal force. Why? Because your P by W equal to V square by GR. V square by GR. Now, if R is infinity, in that case, P by W would be 0, 1 by infinity equal to 0. So, in that case, that would be 0. Now, if there is R, in that case, you will feel that centrifugal ratio, okay, or centrifugal force. So, in such cases, what you have to do? You have to provide the transition curve at the start and at the end point of that circular curve. Now, how you will provide? So, as per the properties of the transition curve has varying radius. So initially it have a radius of infinity, and gradually that infinity will decrease to some point. Okay, so here at that point the radius of the transition curve would be infinity, and gradually it will reduce to r, which is equal to the radius of the circular curve. Okay, so for that reason, what will happen? You will gradually introduce the centrifugal force in the horizontal curve. Okay, so that is the uses of transition curve. So transition curves are used in the horizontal curve in the starting point and at the end point of the curve, and your valley curves are entirely made up of transition curve. Okay, now let us see the types of transition curves. What are the different types of transition curves? Now for the horizontal transition curve, so there are two types of transition curve which is used in the horizontal case, that is horizontal transition curve, and another one is vertical transition curves. So for the horizontal transition curve, the users is gradually introducing the centrifugal force which we have discussed, gradually introducing the design super elevation. Again, if that is a circular curve and that is a straight line, and you know in the circular curve you have to provide the super elevation. Now suddenly you cannot introduce the super elevation. Okay, so you have to gradually introduce the super elevation. If you suddenly introduce the super elevation, then the cross section of the road would be look like this. Okay, that the cross section of the road would be look like this. So in such cases, the vehicle cannot or cross this super elevation portion. Therefore, you need to gradually introduce that super elevation. Okay, gradually introduce the super elevation. So for that reason, you need to provide that transition curve like that, so that vehicle can gradually ascend over there. And another thing, extra winding is also required. So for that extra winding also, if you check if there is only circular curve, in that case, you know, your extra winding should be provided in the circular curve. In that case, it would be look like that only. So suppose that is your circular one, straight line, straight line. So in that case, your extra widening would be look like that. So if you provide the extra widening in that way, in that case, that would be not visually appealing. Okay, so you have to gradually introduce the extra widening also. So for that reason also, your transition curve is required so that you can gradually introduce the extra widening in that uh, horizontal curve. Now there are different types of transition curve. The types are, first one is spiral. Okay, spiral. Second one is your cubic parabola. So basically that is spiral. Second one is cubic parabola, and third one is lemniscate. Now for our case, for the horizontal transition curve, remember for the horizontal transition curve, we use the spiral curve. Okay, now why spiral curve is used? Because in the spiral curve, your rate of change of your radius of that spiral curve is uniform. So if the rate of change of the of that centrifugal radius is uniform or constant, in that case your rate of change of centrifugal acceleration or centrifugal forces is again it would be constant. So if it is consistent and if it is constant, in that case it will be smooth curve. Okay. Now radius of the transition curve is infinity at the straight edge and change to r at the curve point. So which we have already discussed. Now let us discuss about the length of the transition curve, that how you can calculate the length of the transition curve. Now this length of the transition curve should be determined based on the three criteria. So first criteria is rate of change of centrifugal acceleration. Second criteria is rate of change of super elevation, and third one is an empirical formula by IRC. So by all these cases, we will estimate what is the length of the transition curve. Now, after estimating the length of the transition curve, the maximum value among these three values would be our length of transition curve. Now, so how it will happen? So first one is the rate of change of centrifugal acceleration. Now, if C is the rate of change of centrifugal acceleration, your centrifugal force is, let us write it down. Your centrifugal acceleration equal to, okay, and your centrifugal acceleration, only that is your centrifugal ratio, and your centrifugal acceleration is nothing but P into G by W, and that is equal to V square by R. So you just remember your V square by R, that is called your centrifugal acceleration. Basically, that is your centrifugal acceleration. Why it is centrifugal acceleration? Because it denotes the change in V with respect to R. Okay, it denotes the change in V with respect to R. So for that reason, it is your centrifugal acceleration. Now for the centrifugal acceleration, change of centrifugal acceleration, rate of change of acceleration is your v square by r. So initially that was v square by r, but after some time it will reduce to 0, so that is 0. So or initially it was 0 at the start of the transition curve, it was 0, and after that when it uh, attains the maximum radius of r, in that case the centrifugal ratio is v square by r. So the change is v square by r minus 0, and rate of change means you will divide this by t. Okay, that is by unit time how much centrifugal ratio, or sorry, centrifugal acceleration has changed. Okay, so your c equal to v square by r into, now t equal to ls by v. Now how you will find out that t equal to ls by v? Now t is the total time taken for the vehicle to overcome the length of the transition curve. Okay, T is the total time taken for the vehicle to overcome the length of the transition curve. Now, if the length of the transition curves is your Ls, and if the speed of the vehicle is V meter per second, in that case your T is nothing but Ls by V. So instead of T, you write Ls by V, and you will get this equation. Your C equal to V cube divided by Ls into R. So this is the formula for your centrifugal acceleration. Now, basically, we need what is the value of Ls, what is the length of the transition curve. So, you can write down Ls equal to V cube by CR. Okay, Ls equal to V cube divided by CR. Okay, so if V is in meter per second, now if you can directly calculate, you want to directly calculate whether V is in kilometer per hour, in that case you have to use that formula. Now another thing is C. What is the C? C is the rate of change of centrifugal acceleration. Basically you need that value. Now that value is not given, so in that case you have to find out what is the value of C. Now, the value of C could be found out by an empirical formula suggested by IRC. Empirical formula means that IRC or some authors have gone for different testing or different experiments to find out the value of C. After each experiment or after several experiments, they have found out one formula based on their experimental results. So basically, that is an empirical formula. So by empirical formula, you can write down C equal to E divided by 75 plus V, where V is in kilometer per hour. Okay, where V is in kilometer per hour. So from this equation, you can find out what is the value of C. And your value of C should be in between 0.5 to 0.8. Now, if it exceeds 0.8, in that case, you will simply consider the value as 0.8. Now, if it is less than 0.5, in such cases, you will consider the value of C as 0.5. So that is your first thing. That is the rate of change of centrifugal acceleration. Now, your next thing is rate of introduction of super elevation. Now, you know there are different techniques to introduction of super elevation. Okay, now basically in the practical field, what happens? You will introduce the super elevation with respect to the inner edge of the pavement by rotating the pavement above the inner edge, so that outer edge could be in the uh, upper section, or so that super elevation could be provided. Now, if you rotate the inner edge with uh, or if you rotate the pavement with respect to the inner edge, in that case, your total super elevation or total uh, depth of the pavement to be raised would be like that. Let us draw one picture. Suppose that is the pavement. You are rotating this with respect to the inner edge. Suppose that is the inner edge. In that case, okay. So the total width of the pavement which should be required to up or which should be required to be rotated is by this formula E equal to E into B, where E is the rate of super elevation and B is the width of the pavement. Now you know in the horizontal curve where super elevation is provided, in that case you will also provide the extra widening. So your E would be E into W plus WE. So basically that is the total depth or total height of the pavement which should be raised, or outer side of the pavement which should be raised with respect to the inner side of the pavement. Now this total rate of change of this raise, that is from 0 to E. So your total raise of the pavement is E, that is the total depth of the pavement in the outer east portion with respect to the inner portion is E. Now this E, you cannot provide this suddenly. If you provide this suddenly, in that case, what will happen? It will create like a bump structure. Okay, if you go for the cross section of the road, in that case, that cross section would be look like that one. So if the cross section is look like that, in that case, the vehicle cannot overcome this portion. Okay, overcome this portion. So for this reason, you have to gradually introduce the super elevation also. So if you have to provide the super elevation with a gradient of 1 in n over the length of the transition curve. 1 in n means, suppose you are providing the super elevation. Now you know you cannot provide the super elevation suddenly. You have to provide this gradually. Now in that gradual manner also, there are different specification that how much up you have to go for each and every horizontal distance covered. So in such cases, the limiting value or the typical range of the n is 60 to 150. Now, therefore, the length of the transition curve when the pavement is rotated about the inner edge, in that case, it would be n. That is the rate of the change of the super elevation into E. What is the value of E? E is the rate of the super elevation. Now, value of the super elevation, that is small v, you will find out by using that formula E plus F equal to V square by GR plus W, that is the width of the pavement, and WE is the extra widening which if required. Now the thing is, if the pavement is rotated above the central line, now if the pavement is rotated, as I don't know whether you remember or not, suppose that is your horizontal line and your pavement is there, and if that is the axis, and if you rotate this pavement with the inner edge, suppose that is the inner portion with the inner edge, in that case what will happen, that portion will be go up and that portion will be go down like that. So the total super elevation provided over there in any of the side would be half of the total super elevation needed, because half of the super elevation will be provided by it and half of the super elevation will be provided by the other end. Okay, so if that is the case, in such cases, it will have a different uh, ls values. So here W is the width of the pavement, WE is the extra widening, E is the total rest of the pavement, that is E into B. Here B is W plus WE and B is the total width of the pavement, that is W plus WE. Now this is the second condition. Now another condition is there, that is the by minimum length by IRC empirical formula. So by IRC empirical formula for plain and rolling terrain, that value should be based on the IRC standard, and it is LS equal to 2.7 V square by R. And for mountainous and steep region, that equation is V square by R, where V is in kilometer per hour. Now, length of the transition curve would be maximum of these three portions. Just think of this portion and think whether you understand this or not. After that, we'll solve some numerical based on that transition curve. Solve the numerical. So for this numerical, you have to first calculate what is the value of C. Okay. So you have to calculate what is the value of C. So your value of C would be C equal to 80 divided by 75 plus your V is given as 65. So find out what is the value of C. So it is coming around 0.57 meter per second cube. So basically that value lies between 0.5 to 0.8. Okay. So for that reason, you can say that your value of C is within that limit. So you can accept that value. Now your next step is you have to find out what is the value of Ls. So the formula is Ls equal to V cube by Cr. So if you use this formula, in that case, you have to convert the speed value into meter per second, or you can directly use that formula where you can put the value of V in kilometer per hour. So your Ls value would be, as per the first condition, V cube is 65 cube divided by 220. So you will get a value of 47.1 meter. So that is your first thing. Now in the question, it is now you have to go for the second part, that is the rate of introduction of the super elevation. Now in the question, it is again given that pavement is rotated above the central line. So if the pavement is rotated above the central line, in that case your capital E equal to E into V by 2. For the second case, your E equal to E into V by 2. Okay, E into V by 2. So basically you have to calculate what is the value of E. Now how to calculate this E? For the mixed traffic condition, there are three conditions. First, you have to calculate the E, neglecting the friction. So in that case, your formula for the E would be capital V square divided by 225 R V equal to 65 square divided by 225 into 220. So you get the value as 0.08. Now this 0.08, that value is more than your 0.07. Okay, so you have to go for the second step. Now for the second step, what happens? You have to provide the maximum super elevation of 0.07 and find out what is the value of f. So if you calculate the value of f, in that case, that value is minus 0.07. So you will find out that your value of f is 0.08. Now this 0.08 value is lesser than 0.115. So you can consider the maximum super elevation of 0.07 in such case. So your value of small e is nothing but 0.07. Okay. So your E value, capital E value would be 7 into B is given as 7.5 divided by 2. You'll got a value of 0.26. So basically the total E, capital E is the total rise of the pavement and small e is the rate of the super elevation. Okay. So if you draw this, that is basically E, that is the total rise of the pavement, and this rate, this curve rate, how much it is increasing, that is your small e. Okay, so you will get a value of 0.26. So your LS as per the super elevation consideration is LS equal to E into N, where you get a value of E as 0.26 and N is given as 150. Okay, so you will get a value of 39 meter. Okay, this is your second case. Now you have to go for the third case. So in the third case, your LS equal to 2.7 into V square divided by R. So it would be 2.7 into 65 square divided by 220, and you will get a value of 51.9 meter. So your length of the transition curve from the first formula you are getting as 47.1. For the second formula you are getting as 39 meter, and for the third formula you are getting as 51.9 meter. So your length of the transition curve is maximum of these three